Your AI coding assistant? It's not smart. It's a golden retriever with a keyboard. Looks impressive when it types, but leave it alone for 5 minutes and it'll eat your entire code base and wonder why you're mad. That's not the model's fault. That's because nobody put a leash on it. Every agent you've ever used, Claude Code, Codex Cursor, works inside an invisible prison called the context window. It can only hold so many words at once before it starts forgetting what came before. Your agent reads your file, remembers the last few lines, then forgets why it opened the file in the first place. This is why your agent works great for 5 minutes and then becomes a deranged conspiracy theorist about your codebase. It doesn't remember the requirements. It doesn't remember what you asked for 5 paragraphs ago. So how did we get here? First, prompt engineering, write the perfect paragraph, hold your mouth right, and maybe the model does what you want. Then context engineering, RAG, MCP servers, tool calling, stuffing more info in until the model jokes. These are coping mechanisms, duct taping your check engine light. But in early 2026, people realized we don't need better prompts or bigger contexts. We need a different architecture. They called it harness engineering. So what is harness engineering? It's not a framework. It's not a library. It's not LangChain. And look, LangChain was the first attempt at a harness, but it proved we needed something better. Harness engineering is the practice of building the entire environment around your AI agent. The context it sees, the tools it has, the memory it keeps, the permissions it gets, and the feedback loops that catch it when it's being an idiot. Think of it like this. You've got a brilliant but completely unhinged junior developer. They need a clear spec, that's your requirements file. Tools they can use without burning the house down, your MCP servers and API access. Someone checking their work, your eval loop. A harness is all three. Here's the part that actually blew my mind. Every successful harness runs a simple cycle. Give the agent one task with fresh context, let it work, check the output, feed the result back, repeat. It's not the model that makes it work, it's the loop. Most people use AI backwards. They dump their entire project into one chat and ask for the Mona Lisa. Context gets polluted, it forgets the beginning, the output's a disaster. A harness breaks work into micro iterations, each with a clean slate, each building on verified results. The key insight, each iteration gets a fresh context window. The model does one thing, passes the result, moves on with clean eyes. It's like a surgeon who scrubs in for every stitch instead of operating for 12 hours straight. Way less drama. Way fewer mistakes. So Claude Code, that's a harness. Codex from OpenAI, also a harness. They're not just models, they're the model plus a system of tools, permissions, and loops. The open source ecosystem is exploding, hundreds of stars per day on harness engineering repos. And here's the thing, the core loop of a harness is embarrassingly simple. A requirements file, a task loop that reads one task at a time, a test cycle, a feedback mechanism. The core fits in maybe 100 lines. People think this requires Kubernetes. It requires a for loop and the willingness to actually check your agent's work. Why should you care? Because the shift from prompt engineering to harness engineering is the biggest change in how we use AI since ChatGPT. Prompt engineering is transforming into system design. Writing the perfect paragraph to trick a model, that's voodoo. Designing feedback loops and agent architectures, that's real engineering. Right now, almost nobody can do this well. Companies are already looking for people who can build harnesses. That's you, after you finish watching this video. Okay, but let me be real. A toy harness in 100 lines is one thing. A production harness that handles permissions, state persistence, eval pipelines, error recovery, and security. First, debugging an agent loop is a nightmare. When your agent fails on iteration 7, you can't just look at the error. You replay the entire trajectory, every context, every tool call, to find where it went wrong. The tools for this exist, but they're young and painful. Second, evaluation. How do you know your harness is good? You need benchmarks, regression tests, a way to measure if your changes actually improve the agent or just make it differently wrong. Third, security. Your agent has access to your code base, API keys, infrastructure. A bad harness is a security breach waiting to happen. The good news, harness engineering naturally addresses this. You define exactly what the agent can do and the harness enforces it. Design for it, don't bolt it on. And this isn't theoretical. OpenAI published on harness engineering in February. Martin Fowler followed in April. There are already production harnesses, some cloud hosted, some locally run, and the open source community is contributing faster than anyone can keep up. This is the rare trend that's actually happening while you're watching a video about it. So here's the takeaway. AI models are getting smarter every month. But a smarter model with a bad harness is just a faster idiot. The ones who win, the developers who actually ship, are the ones who treat the harness as seriously as the model. The best harnesses give you a choice. Cloud hosted when you need top tier capability, locally run when you need privacy. You don't have to send your entire code base to a third party. A locally run agent in a well designed harness, producing work you can actually trust. No cloud required, no context window anxiety, just an agent that does what you tell it. Because the environment makes any other outcome impossible. That's harness engineering. Go build one.